this video, we're going to continue looking at exploratory analysis, and in particular, we're going to look at the Table 1 package. So as usual, I have our Module 9.2 script from Canvas that I've opened up in RStudio. And to start out with here, I've got just a little bit about the Table 1. So just like in the previous module, information about this package is not in your book, so I'm going to be using this website that I have listed here. And below I have a little bit about Table 1 from that website. So it is an R package, and what it does is it eases the construction of what they call Table 1 here. And this is really what you would see at the beginning of an article that you might write, and it's really just a table that summarizes all of the variables in your data set. So the nice thing about this package is it can summarize both categorical and continuous variables, and it will mix them within one table. But as always, I wouldn't just copy and paste this table into, whatever you're using to write your paper, but instead, I would move these values over and then format your table to look nicer depending on what journal or what avenue it is that you're writing the table or the paper for. Alright, so the first thing we're going to need to do is get the Table 1 package. So again, as a reminder, we always call it using the library, but the first step is to make sure you have it on your computer, and to do that you can either go up here and do the install package, or you can run the install.package function to call it in. And then we're going to look at two different data sets. Both of these we have seen before. So we have the diabetes data from last time, and we have the supraclavicular curve data that we looked at in one of the previous labs. So I'm going to go ahead and read both of these in. And you don't have to run the view. I just usually include that as a reminder to myself if I want that to view. But that's why, since I don't really need to view them right now, I just went ahead and closed out. Alright, I would like to just remind ourselves before we go and look at the actual function of what is in these data sets. So looking at the diabetes from last time, remember that we have 9 variables. Here's the different variables, and so looking through here, notice for the diabetes data, majority of these are going to be quantitative. So all of these are quantitative, with the last one, outcome, being categorical. And then if we view the data set that we previously looked at in lab, notice that group and gender are both categorical, but all of the other ones were quantitative. So let's start out by looking at the diabetes data set first and see what happens when we use this function, create table 1. And this create table 1 is part of the Table 1 package. Alright, so if we run this, what this package does is for each of the variables, by default, if it's quantitative or continuous, it's going to give mean and standard deviation. If it is categorical, it will give the percent for the different outcomes. So the first thing it's always going to give us is n, which is the number of observations. So this data set does have 768, and that matches up here. And then for each of the quantitative variables, it gives us the mean and the standard deviation. And then finally, for the last one, which was categorical, which is outcome, whether or not the person had diabetes, it tells us the percentage and the count for yeses. So there were 268 yeses, which accounted for 34.9% of the data set. Now, it doesn't automatically give you the no's because there were only 2 variables, or probably 2 potential outcomes. So if you know the percentage and count for yeses, you automatically know the percentage and count for no's. You can force it to print those, and I'll show you that in just a moment. Let's look at the same function but applied to our other data set. So notice here we just said that group and gender were categorical, but this time it gave it to us as a mean and standard deviation. If we go and we look at our data set, notice that group and gender are recorded as either 0s and 1s or 1s and 2s. This is very common for categorical data to be recorded as numbers when placed into a data set. So we do want to be careful here because this is incorrect. This is not how we would want to summarize these 2 categorical variables. So what we actually need to do for a data set like this one is do a categorical variable conversion. And I'm going to show you how to do that. So the first thing we're going to do is run this line of code. This is going to give us all of the names in our data set. And what this dput does that's really nice is notice in the output here it automatically put the C in the parentheses. All of my names are separated by commas and in the quotations. This is really nice because now what I can do if I wanted to list all of the variables in my data set, this automatically gave me the code. So I can just copy this, and the next thing I'm going to do is I am going to define what variables I want to summarize. So I have already done this, but I'm just going to replace this. So I'm going to copy that in. And one thing notice here is the very first thing we have is subject. Well, subject is just the ID number. I don't really need a mean and a standard deviation for subject number because it doesn't have any intrinsic meaning. So that's a variable that I don't actually need to summarize. So I'm actually going to take it out. I don't need the summary for that one. And then the next thing I'm going to do is specify a vector of the categorical variables. So here I want group and gender to be my two categorical variables. Now, group and gender still need to be included in the list with all of the variables as well. So next, to create my table, and this time I'm going to assign the table to be an object table2. I'm still going to use the create table1 function, but now I'm going to give it some more arguments. The vars argument are going to be the variables that I want to summarize from the data set. So really the only thing I took out here was the subject number. And then factor vars, those are going to be where I give it the vector that holds the categorical variables. And so you'll notice I have cat vars here. Alright, so let's run this. And then here at the end I'm calling table2 so it will print out. Alright, so here's my new table. Notice I have N, which is the number of observations in this data set, which was 103. Now for group, I don't have mean and standard deviation anymore, which is exactly what I don't want mean and standard deviation. I wanted to get a count and a percentage. So for group is equal to 2, I see over here there were 51 is my count for people in group 2. And then that accounts for 49.5% of the sample. And then similar for gender. And then you'll notice for all the other variables, we have the mean and standard deviation since they were all quantitative. Now, let's say I didn't just want to see for group equals 2, I wanted to see for all the levels of groups and all the levels for gender. Then what we can do is use this print statement, and I'm going to call table2. I'm going to set the argument show all levels equal to true, and then this is just a formatting option to make it a little bit easier to read. So running this. Alright, so now for group 1, or probably for groups, my possible options are group 1 or group 2. There were 52 people in group 1, 51 in group 2, and here are the corresponding percentages. For gender, we have 0 and 1. And then we have the corresponding counts and percentages. Now, of course, we always have to go back to our code book, just like we saw in lab, to see what group 1 and 2 correspond to, and gender 0 and 1 correspond to. And then I have the mean and the standard deviation for all those quantitative variables. Alright, something else that I might want to do is if we look through here, notice if I look at fentanyl, notice that fentanyl, if I look at the mean and the standard deviation, I apologize, I've skipped a step. If we want to pull out some more information from table 2, not just the mean and the standard deviation, we can use summary table 2. So let's run summary table 2. And so notice by running summary table 2, we're going to get a lot more information about each of those variables. So we get the number of observations for each, the number that are missing, percent of them that are missing, mean, standard deviation, median, first and third quartile, min and max, and you also get what's called skewness and kurtosis. Alright, if we look at fentanyl, so this variable right here, Notice that the mean for fentanyl is 21.32 and the median is 0. This suggests that fentanyl is a highly skewed variable. So for highly skewed variables, we generally don't want to use mean and standard deviation as our summary. We would want to use median and IQR. And so we can force the table to include that as well. If you have any variables that are skewed, that would be better summarized by mean and IQR. What we can do is we can create a variable called skewed, and it'll be a character vector with the names of any variable that we would like to show the median and IQR for. Then when we go to our print table, notice there's a new argument I've added in here called non-normal, and I've set it equal to skew. Everything else is the same that I have up here, although this time I did leave out the show all levels, but we could put that in. So let's run this. So now notice in my table, fentanyl is now summarized using median and IQR instead of mean and standard deviation. So that's another option that you can add in. And then the last thing that we'll look at is we may want to summarize these by group. So if you'll remember, for this particular data set, we had two different groups. We were comparing group 1 and group 2. So to do this, when we run the line of code to create the table, we add in what is called strata. And so for the strata argument, we set it equal to the variable name that specified the groups. So for this data set, that variable name was group. And then I'm going to use the print table function down below, or the print function. And so notice now I actually get two tables that are stratified by group. So this table is just summarizing group 1. So notice in group 1 I shouldn't have anybody in group 2. So next to group equals 2, notice I have 0. This table is going to summarize group 2, and notice for group 2 I have all 51 or 100% of them in there. So do be careful that these percentages, once you stratify by group, these percentages are no longer for the overall data set. The percentages are going to be within group. So for example, when we look at gender and we see that gender equals 1 and the percentage is 52.9, 52.9% of group 2 had gender 1. And if we come up here, 36.5% of group 1 had gender 1. So do be careful when you look at those percentages. They are slightly different than when we did not stratify by group. So again, the idea here is we're doing that exploratory analysis, and so this is the nice way if you have a lot of variables that you can create a quick table where you look at some important summary statistics for those different variables. So as always, if you have any questions, please let me know.